Hello students, this is Harish Konda. Welcome to my channel, the chemistry class. So, with your cooperation across the 100, please keep on cooperate. So, our next target to reach 500 with your cooperation. Thank you. So, today we are going to start the Eamcet in Eamcet. The next topic, that is chemical bond. The chemical bond, from the chemical bond we have 2 marks. The topic we are going to discuss. So, generally the atoms, when they are combined, the atoms when they are, for example, we have 2 atoms A and A, when they are combined each other. So, here the 2 atoms are getting attracted. The 2 atoms are getting attracted and they are bind together. The 2 atoms are bind together. Because of their attraction, that type of binding is called chemical bond. Why? Because due to the chemical activity, the 2 atoms are get binded. Such type of bond, such type of binding is called chemical bond. So, how they are attracted, how they are combined, we have to discuss. About the chemical bond, we have to discuss how it is formed. So, what are the attractions between the atoms are occurred? That we have to discuss. So, generally the chemical bond we have 4 types. The one is called ionic bond, the second is called covalent bond, and the third is called coordinate covalent bond or dative bond, and the last one is hydrogen bond. So, these 4 bonds today we discuss for your Eamcet. Okay. So, one by one we discuss. So, in chemical bond, the first one we are discussing about the ionic bond, how the ion bond is formed. Here, to form the ionic bond, so that name itself indicates, so what we have to form, the ions we have to form. The ions are involved in the bonding. So, that's why it is called ionic bond. So, we have to know, we know about the atoms, we know about the molecules, we know about the elements. What are the ions it is? So, how the ions are formed? In ionic bond, what they are involved, the ions are involved. So, when the ions are involved, automatically one bond is formed. That bond is called ionic bond. How the ions are formed, we have to know. So, generally we have 2 type of ions. How many type of ions we have? 2 type of ions. The one is called cation and the other one is called anion. These 2 ions, when they are combined, so what the bond is formed? Ionic bond is formed. So, here the 2 ions are formed. The one is cation and the second is anion, which is having the positive charge. The positive charged ion is called cation. The negative charged ion, it is called anion. So, here the ionic bond, the ions are involved. What are the ions we have? 2 ions we have. One is called cation and the other one is called anion. So, cation it is having positive charge and anion it is having the negative charge. So, the 2 opposite ions are forming. When 2 opposite ions are formed, they are getting attracted here when the positive ion and the negative ion, they are getting attracted because they are opposite charged ions. So, when they are get attracted, so automatically the compound you are forming. So, what you are forming? The compound you are forming. The ions are involved to form a compound. So, in the compound, in the ions are having a bond. That bond is called ionic bond. So, now we have to know about the cation and anion, how the cation is formed, how the anion is formed. Very first we discuss about the cation, which is having the positive charge, that is called cation. Generally the elements when they lose the electron, what they form? The cation they form. The elements when they are losing the electron, what they form? The cation they form. Why they lose the electron? They have to get the stability. To get the stability, nearby inert gas configuration they has to form. For example, we discuss one example, the sodium. The sodium atomic number is 11. So, it is very close to neon inert gas, the neon atomic number is 10. So, here the sodium is in between neon and argon. The argon atomic number is 18 and the neon atomic number is 10. So, sodium atomic number is 11. It is having 11 protons and at the same time it is having the 11 electrons. To get stability, it has to get the neon configuration and it has to get the argon configuration. If you want to get neon configuration, it has to lose one electron. When one electron is lost, the sodium is getting neon configuration. When the 7 electrons are gained by sodium, what you are getting? The argon configuration you are getting. So here the sodium, instead of gaining the electrons, it loses the electron to form neon configuration. Why? Because the losing electrons are only one. It is very easy to lose the electron. So the sodium is losing one electron to form the neon configuration. So always the sodium is losing by one electron. So it is getting the stability. So when that electron is loose, what happened here you see, before the losing of electrons, we have 11 protons and 11 electrons. That means 11 plus charges and 11 minus charges. The sodium is having 0 charge. When that sodium is not lose the electron, before losing the electron, the sodium is having 11 protons, so 11 plus charges, 11 electrons, that means 11 minus charges. It is having 0 charge. But what happened here it is, one electron is loose. When one electron is loose, the sodium is getting neon configuration. So when one electron is loose, the protons are not changed, there is 11 protons only. But the one electron is loose, so instead of 11 electrons, we have 10 electrons only. One electron is loosed by the sodium. So 11 protons, we are getting 11 positive charges. 10 electrons, we are getting 10 negative charges. Automatically, 1 plus charge is excess. So automatically, the sodium is getting 1 positive charge. Na plus ion is formed. The cation is formed. When the element is losing the electron, what you are forming? The cation, positive charge ion you are forming. Here 1 electron is loose, 1 positive charge is formed. 2 electrons are loose, 2 positive charges are formed. 3 electrons are loose, 3 positive charges are formed. Like that ions are formed. For example, magnesium you take, the magnesium it is 12. If it is want to get neon configuration, compulsory how many electrons it has to lose? 2 electrons it has to lose. When the 2 electrons are loose, what you are forming? The magnesium plus 2 you are forming. Here you see the aluminum. Aluminum atomic number is 13. To get the neon configuration, it has to lose 3 electrons. Al plus 3 is formed. So like that, the ions, when the element are losing the electrons, so what you are forming? The cations you are forming. It is vice versa. When the electrons are gained by the element, so automatically gained by the atom, automatically negative charges are formed. For example, we take one example, that is fluorine. The fluorine atomic number is 9. It is very close to helium and neon. The helium atomic number is 2, neon atomic number is 10. The fluorine is in between helium and neon. So helium is atomic number 2 and neon atomic number 10. So the fluorine to get the stability, what has to do? To lose 7 electrons to get helium configuration or gain 1 electron to get neon configuration. Why? Because the fluorine is in between helium and neon. If it is getting helium configuration, it is stable. If it is getting neon configuration, also stable. So to get helium configuration, it has to lose 7 electrons. To get neon configuration, it has to gain only 1 electron. So it is very easy to gain 1 electron instead of losing 7 electrons. Gaining 1 electron is very easy. So fluorine is always gaining 1 electron to get the stability. So what happened here you see, before gaining the electron, here the fluorine is having 9 protons and 9 electrons. Why? Because the atomic number is 9. So 9 protons means 9 plus charges and 9 minus charges. The fluorine is having 0 charge. But here what happened? So here what happened? 1 electron is gained. The protons are not changed, same only. But the electron is gained automatically. How many electrons are getting? 10 electrons. So 10 electrons means 10 minus. So 10 minus charges you are formed. So what happened? 1 minus charges is excess. So that fluorine is getting 1 negative charge. Here you see what happened. When the atom is gaining the electrons, what you are forming? The negative charged particles you are forming. Negative charged ions you are forming. That is anions you are forming. how many electrons are gained equal to the negative charge? One electron is gained, so F minus 1 is formed. For example, 2 electrons are gained, O minus 2 is formed. 3 electrons are gained, N minus 3 is formed. Like that the ions are formed. Here the cation and anion are involved in ionic bonding. So to form the cation, the elements have to lose the electron. To form the anion, the elements has to gain the electron. When how many electrons are lost, that is equal to the positive charge. How many electrons are gained, that is equal to the negative charge. So automatically one cation and one anion is formed. So here you see what happened when the sodium is very nearly approached by the fluorine. The sodium, when it is very nearly approached by the fluorine, what happened? To get stability, the sodium has to lose one electron, and what you form? Na plus ion is formed. This electron is completely transferred to the fluorine. Why? Because the fluorine is required the electron. The fluorine is required the electron. So that electron is gained by the fluorine. So what happened here? You see the fluorine electron is gained and F minus 1 is formed. Here the sodium and fluorine, when they are closely approached, when the fluorine is getting very close to the sodium, what happened here? The sodium is losing one electron, that electron is gained by the fluorine, the sodium is getting positive charge and the fluorine is getting negative charge. So the two opposite ions are formed. They are very close together, so automatically they are getting attracted, and what you form? The sodium fluoride compound you are formed. One ionic compound you are formed. What you form? The ionic compound you are formed. Why? Because it is ionic. The sodium is having the positive charge and the fluorine is having negative charge. Two ions are involved. In the compound, two ions you are getting. So that's why the compound is called ionic compound, because of in the ionic compound, what are the bond you are forming? That ionic bond you are forming. Due to the electrons are gaining and losing, so you are forming two ions. They are very close and they are get attracted, and one compound you are forming. So that is called ionic bond. Generally the ionic bond. So here how many cations are involved? How many anions are involved to form the compound? Here we see that is called valency, electrovalency. Here the sodium is losing one electron, so it is bonding with only one fluorine. For example, magnesium, if you take, magnesium is losing two electrons, so with two fluorines it is bonding. Aluminum is losing 3 electrons, so with 3 fluorines it is bonding. So how many electrons are lost? That is equal to the bonding. So it is called electrovalency of that element. The sodium valency, electrovalency 1, the magnesium electrovalency 2, the aluminum electrovalency is 3. So like that the valency we are discussing. Similarly, how many electrons are gained? That is equal to the bonding. You see, here the fluorine is gaining only one electron, the sodium with one sodium only it is bond. For example, the oxygen you take, the oxygen is gaining 2 electrons, 2 bonds are formed. The nitrogen is gaining 3 electrons, 3 bonds are formed. That is called electrovalency. So to get this ionic compounds, so what are the principles here involved? The Fasan rule is involved. The Fasan rule, what it is? So how the cation is formed, how the anion is formed. Very easily cation, very easily the anion is formed. Automatically the compound is ionic compound only. Why? Because how fastly the cation, how fastly the anion is formed. Based on that only ionic compounds are formed, ionic bond is formed. So that discussed by Fasan. So it is called Fasan rule. To get the Fasan rule here, to form the cation, it should be very large sized atom. The cation should be large size and less ionization potential and less charge. Here you see these 3 particles, the sodium and magnesium and aluminum. Here sodium is usually losing 1 electron, magnesium has to lose 2 electrons, aluminum has to lose 3 electrons. So sodium easily formed when you compare with the magnesium, when you compare with the aluminum. Why? Because as per the Fasan rule, how much charge is formed? Very less charged cations are very stable when you compare with the other cations. Why? Because it required only 1 ionization energy. But for this magnesium we need 2 ionization energies. For aluminum you need 3 ionization energies. Like that the anion, the cation is very large size and less cationic charge. So like that the cations are formed and the anions very small size and less charged one. So to easily form the anion should be very less sized and the charge should be less only. That is called Fazan's rule. So the second bond we are discussing, that is covalent bond. The covalent bond is introduced by Lewis. The Lewis introduced the covalent bond. Here now only we discussed about the ionic bond. There the electron completely transferred one atom to the another atom. Their ions are involved, so it is called ionic bond. But here instead of transferring one electron, here the electron pair is shared. The electron pair is shared between the two atoms. Now that type of bond is called covalent bond. For example, we discuss here the A atom is there. So it is, and one more A atom is there. Instead of one electron transferred to another A, here what happened here? The two electrons are mutually shared. The two electrons are mutually shared in between two atoms. So what the bond is formed, that is called covalent bond. So how we show? Before, in between the atoms we are showing a line, a hyphen line. So we are showing the covalent bond. Here the two electrons are shared between two atoms. So automatically the bond is formed. The bond is called covalent bond. To explain the covalent bond, here we have so many theories. So here very firstly what you say, the covalent bond, how it is formed? By Lewis we form. So for example, I am taking one element, that is fluorine element I am taking. The atomic number is 9. So what is the electronic configuration? It is 1s2, 2s2, 2p5. So in 2s orbital we have 2 electrons, in p orbital we have 5 electrons. So here we have only one unpaired electron. This unpaired electron is mutually shared with another fluorine unpaired electron. So compulsory to form the covalent bond. So what is the condition? It is one compulsory unpaired electrons are involved. The unpaired electrons only involved in covalent bond, not the paired electrons. So when we have unpaired electron, that only forms the covalent bond. So how many unpaired electrons we have, that is equal to the bonding. So here the fluorine is having only one unpaired electron that is involved in covalent bond. So we take another fluorine. The same fluorine we are taking. The atomic number of fluorine is 9, same. The electronic configuration is 1s2, 2s2, 2p5. Here in 2s orbital we have 2 electrons, in p orbital we have 5 electrons. So here we have one unpaired electron. So the s2 electrons are helium configuration, and 2s2 in 2p5 we have only one unpaired electron. In 2s2 2p5 it is called valency orbit. The electrons are called valency electrons. In that valency electrons we have one electron, one unpaired electron. That unpaired electron only involved in covalent bond, that is discussed by the Lewis. It is called Lewis dot method. What is the method you are called? Lewis dot method. So how we are writing the Lewis dots, we see. So here the valency orbit electrons are shown as a dots. For example, you see how many electrons we are in valency orbit? 2 plus 5, 7 electrons we have. In that 3 are paired, 1 is unpaired. So what I am showing here, you see the 3 are paired and 1 is unpaired electron. Similarly, second fluorine also we have. In the second fluorine, what happened here? The same 3 are paired electrons and 1 is unpaired electron. So here the fluorine, to get the stability, the fluorine has to share with that electron of opposite fluorine. So what happened here, you see. So here this electron is mutually shared with the fluorine. So the fluorine is getting octet. Why? Because here you see the 3 pairs, and here with the other fluorine electron we are getting one more pair. So here how many pairs are formed? 4 pairs are formed. That means octet is completed. Similarly, this fluorine also getting the octet. Why? Because already 3 pairs are there. One new pair is formed. So the fluorine is getting octet. So here you see, in these pairs, the one is getting bond pair. The pair is called bond pair. Why? Because of the bond only that pair is formed. So this pair is called bond pair. These 3 pairs are called lone pairs. So here how many pairs you are getting? Totally 4 pairs. So the fluorine is getting octet. It is getting stable. So similarly, one more example will take. So here For example, we take chlorine. The atomic number of chlorine is 17. So what happened here? You see 1s2, 2s2, 2p6 and 3s2, 3p5. What is the electronic configuration of chlorine? 1s2, 2s2, 2p6, 3s2, 3p5. What is the outer shell? It is 3s2, 3p5 is the outer shell. That means, so it is the valency orbit. That orbit is called valency orbit. The electrons are called valency electrons. In 3s orbital we have 2 electrons. In 3p orbital we have 5 electrons. So here how many unpaired electrons? We have only one unpaired electron. So how many covalent bonds are formed by the chlorine? Only one. So here you see the chlorine. So Lewis dots we are showing here. The 3 pairs I am showing with the dots and one is unpaired electron. Same similarly, one more chlorine we are taking. The chlorine also same atomic number 17, same electronic configuration 1s2, 2s2, 2p6, 3s2, 3p5. So here outer shell it is 3s2, 3p5. In s orbital we have 2 electrons, in p orbital we have 5 electrons. So here only one unpaired electron we have, that unpaired electron only involved in covalent bond. So the same similarly we are showing the chlorine. So the 3 are paired one and one is unpaired. So automatically what happened here, you see the chlorine is getting shared. That electron, unpaired electrons are shared. So what happened here, see the unpaired electron when it is shared, the chlorine is getting 4 electron pairs. That means 8 electrons it is getting octet. Same similarly this chlorine also getting octet. Why? Because 3 are paired. Already one pair is forming because of the bond. One pair is formed. Totally 4 pairs are formed. That is octet it is forming. Same similarly one more example we'll take. So for example oxygen we have the atomic number is 8, electronic configuration 1s2, 2s2, 2p4. What is the electronic configuration? 1s2, 2s2, 2p4. In s orbital we have 2 electrons, in p orbital we have 4 electrons. So now you see that 2 unpaired electrons you have. In the oxygen 2 unpaired electrons you have. That oxygen paired electrons and unpaired electrons I am showing in the Lewis dot method. So it is the paired electron. This is also paired electron and 2 unpaired electrons you are forming. The oxygen is having 2 unpaired electrons. Same similarly one more oxygen we take. In that oxygen also the atomic number is 8. Electronic configuration same 1s2, 2s2, 2p4 only. So 2s2, 2p4 is the outer orbit. In 2s orbital we have 2 electrons. In p orbital we have 4 electrons. So here in the oxygen the same similarly 2 are paired electrons and 2 are unpaired electrons. These unpaired electrons are mutually shared and one bond you are forming. So here the 2 electrons when they are shared one bond is formed. The 2 electrons when they are shared one more bond is formed. Here in between the oxygen atoms how many bonds are formed here? 2 bonds are formed. So here 2 bond pairs and 2 lone pairs you have. How many electron pairs you have? 4 electron pairs. That means 8 electrons you are formed. That is octet is completed. Same similar here this oxygen also getting the octet. That oxygen also getting stable. So here the oxygen that atomic number it is 8. 1s2, 2s2, 2p4. In outer shell we have 6 electrons. The 6 electrons and the next item also you are having the 6 electrons. The 2 unpaired electrons when they are mutually shared. So automatically the 2 covalent bonds are formed. One more example we take. The hydrogen we take. The atomic number is 1. What is the electronic configuration? It is 1s1. In hydrogen you have 1 electron. Same similarly for example the fluorine you take. The atomic number 9. 1s2, 2s2, 2p5. So in fluorine you have 3 pairs and one is unpaired. So that hydrogen is getting helium configuration. At the same time the fluorine is getting octet. So that is neon configuration. So in between the hydrogen and fluorine one covalent pair are formed. So here you see the chlorine Cl2 is formed. It is homoatomic molecule you form. The oxygen O2 you form, that is homoatomic molecule you form. The hydrogen fluorine, that is HF you form, heteroatomic molecule you form. So the covalent bond is formed in between the atoms to form the molecules. With the Lewis dot method we explained this one. So in the outer shell electrons we are showing with the dots. If the pairs the pairs are shown. If the unpaired is shown. The unpaired electron only is shared with another unpaired electron to form the covalent bond. This method is called Lewis method. Lewis dot method. So now only we discussed about the covalent bond with the Lewis method. To explain the covalent bond, here we have three theories. The one is called VBT, valency bond theory, and second is called Vesper theory, valency shell electron pair repulsion theory. So what it is called? Valency shell electron pair repulsion theory. It is called Vesper theory, and the third one it is called hybridization. So these three principles, the three rules, the VBT, the theories, they are explained about the covalent bond. The one is called valency bond theory, the second is called Vesper theory, and the third it is called hybridization theory. By these three theories, we can explain how the covalent bond is formed. So now we discuss about the VBT. So in the VBT, the valency bond theory, here how we discuss the covalent bond, how the covalent bond is formed, very risky. In the valency bond theory, the valency orbits, in the valency orbit we have the electrons which are having the electrons orbitals. The orbitals are involved in covalent bond. So as per VBT, the valency orbit electrons, what they are in the orbitals are involved in the bonding. That bond is called as per VBT. So what happened here? The valency orbit electrons. So what they are in the orbitals, that orbitals are involved in the bond formation, covalent bond formation. That bonds are called, that theory is called VBT. So how it is we see. For example, the hydrogen we take, the hydrogen atomic number is 1. So what is the electronic configuration is 1s1. So in 1s orbital we have one electron. The unpaired electron, it is in the s orbital. So in hydrogen, so what orbital is involved in the covalent bond? That s orbital is involved in the covalent bond. So one more hydrogen I am taking the same one electron, atomic number is 1. So electronic configuration is 1s1. So in 1s orbital we have one electron. So the unpaired electron in s orbital, in this hydrogen also the unpaired electron in the s orbital, that s orbitals are involved in bond formation. So as per VBT, the valency electron which is in the orbital, the orbitals are involved in the covalent bond. How they are involved? How they are bonding? So we see. So here the s orbital, it is in spherical shape. The same similarly the s orbital also in the spherical shape. That s orbital is having one electron. Same similarly this s orbital also having the one electron. So here, so to form the bond, what happened here you see, we have to form one axis. That axis is called internuclear axis. In the internuclear axis, what happened you see, so here the hydrogen, it is the nucleus of the hydrogen. Same similarly it is the nucleus of the hydrogen. So what happened here you see, the two nucleus I am combining with the axis. This axis is called internuclear axis. In the internuclear axis, the two orbitals are get overlapped. What happened here? The two orbitals are get overlapped to form the covalent bond. On the internuclear axis only they are overlapped. How they are overlapped? The two orbitals are overlapping. What it is you see? So it is one s orbital, it is another s orbital. The two s orbitals are they're getting overlapped. Like this they are overlapping each other. So automatically what happened here? One covalent bond you are formed. In the internuclear axis, the overlapping is occurred. When the overlapping is formed, so automatically you are formed one bond. That bond is called covalent bond. These two s orbitals, they are interlinked. They are overlapped in the nuclear axis. So automatically you see here the s orbital, the two are overlapped on the axis. The two electrons are mutually shared. So automatically what happened? One bond you are formed. So it is the hydrogen s orbital. It is the hydrogen s orbital. The two s orbitals are overlapped. So this overlapping is called SS overlapping. Why? Because the s orbitals are involved in the overlapping. So this type of overlapping is called ss overlapping. When in the internuclear axis, the two orbitals are overlapped. So what bond you are formed? That bond is called sigma bond. What is the bond? It is called sigma bond. So in the hydrogen, the two s orbitals, they are overlapped. In the internuclear axis only they are overlapped. The two electrons are shared. One bond is formed in between the hydrogen and hydrogen. So here what happened? So the two s orbitals are involved in overlapping. How they are overlapped? In the internuclear axis only they are overlapped. So the bond what you form, the bond is called sigma bond due to SS overlapping. What is overlapping? It is SS overlapping. So one more example we'll take. For example, one hydrogen I am taking and the another one is chlorine I am taking. Or instead of these two, so we take one more example. So here it is one fluorine we are taking and the second one also fluorine I am taking. The fluorine atomic number is 9. Here the fluorine atomic number is 9. What is the electronic configuration? The 1s2, 2s2, 2p5. Here also 1s2, 2s2, 2p5. So here the electronic configuration, outer shell, valency orbits only involved. So valency orbit is 2s and 2p. So in 2s orbital we have 2 electrons, in 2p orbital we have 5 electrons. So unpaired electron, it is in p orbital. Even though we have 3 p orbitals, one unpaired electron in 1 p orbital. So similarly here also, that is 2s2, 2p5, the unpaired electron in p orbital. So what the orbital is overlapped here? Unpaired electron p orbital is overlapped. Here the fluorine is having one p orbital with one unpaired electron. Similarly, one more fluorine also having the same p orbital with one electron. Here what have to form? So one internuclear axis we have to form. Here the fluorine center, it is a nucleus. This is the one more fluorine center, it is a nucleus. So what I am forming? One internuclear axis I am forming. In the internuclear axis only, these two p orbitals are overlapped. So it is a fluorine p orbital, it is another fluorine p orbital. So what happened here? One internuclear axis is formed. In the axis, the two p orbitals are overlapped. When the two p orbitals are overlapped, so automatically one bond is formed. The bond is called covalent bond. Here the fluorine p orbital and another fluorine p orbital. These two p orbitals are overlapped. So the overlapping is called pp overlapping. In the internuclear axis, when they are overlapped, the bond is formed. That bond is called sigma bond. So here what bond is formed? The sigma bond is formed. Here one fluorine and with another fluorine, one covalent bond is formed due to pp overlapping. So what bond you are forming? The sigma bond you are forming. So one more example we will take. So one is hydrogen and another one is fluorine we take. The hydrogen atomic number is 1. The electronic configuration 1s1 in electron, then 1s orbital. The unpaired electron in s orbital. And similarly the fluorine you take. The fluorine atomic number is 9. So electronic configuration 1s2, 2s2, 2p5. So unpaired electrons are in p orbitals. So unpaired electron in p orbital. So here what happened, you see? The hydrogen is having s orbital, 1 electron, and the fluorine is having p orbital and 1 electron. So what have to do? So we have to form one internuclear axis. One internuclear axis form. In the internuclear axis only the two orbitals are overlapped. Here the s orbital and the p orbital, the two are overlapped and one bond is formed. Here the hydrogen s orbital and the fluorine p orbital. So what is the overlapping? It is sp overlapping. So when the internuclear axis the overlap is formed, so what the bond you are formed, that is called sigma bond. In hydrogen and fluorine, one covalent bond is formed due to sp overlapping, and what the bond you are formed? The sigma bond you are formed. So that is VBT, valency bond theory. In the valency bond theory, the valency orbitals, when the valency orbital unpaired having orbitals, they are involved in the bond formation. So which is unpaired electron in the orbital, they are overlapped each other. So how they are overlapped? In the internuclear axis only they are overlapped. And what the bond you are formed? In sigma bond you are formed. In some examples, so here we take one example, that is oxygen. Atomic number is 8. Electronic configuration 1s2, 2s2, 2p4. Outer shell electronic configuration is 2s2, 2p4. In s orbital we have 2 electrons. In p orbital we have 4 electrons. So here we have 2 unpaired electrons. How many bonds it can form? 2 bonds it can form. Why? Because in 2 p orbitals we have 2 unpaired electrons. Unpaired electrons are involved in covalent bond. So 2 unpaired electrons we have. So the compulsory oxygen should form 2 covalent bonds. The second oxygen also we take. The second oxygen atomic number is 8. Same electronic configuration 1s2, 2s2, 2p4 only. So outer shell it is 2s2, 2p4. In s orbital we have 2 electrons. In p orbital we have 4 electrons. So here also oxygen is having 2 unpaired electrons. So what happened you see? So the p orbitals are dumbbell shaped. So here one px orbital and another one is py orbital and pz orbital. We have 3 orbitals. In px orbital 1 electron is there. In py orbital 1 electron is there. In pz orbital we have 2 electrons. So the 2 are coupled electrons. The paired electrons, they are not involved in covalent bond. Similarly one more oxygen I am taking. So there is 3 p orbitals. In 3 p orbitals one is unpaired electron. Here also having unpaired electron. It is paired electron. So one is paired electron and one is unpaired electron. In py orbital we have one unpaired electron. In pz orbital we have paired electron. So here you see what happened. So we are forming one internuclear axis. It is oxygen nucleus. It is oxygen nucleus. One internuclear axis you are formed. In the internuclear axis one overlap is occurred. So what is the overlapping? It is oxygen p orbital. This is also oxygen p orbital. One nuclear axis is formed. That internuclear axis we have overlapped and one sigma bond is formed. After one overlapping, so what happened you see, for example, so it is the oxygen atom. So here we have 3 orbitals, the px, py and pz. So here px orbital is having one unpaired electron. This py orbital also having one unpaired electron. This pz orbital is having paired electron. Similarly one more oxygen we take. Here also we are having one unpaired electrons and paired electrons. So here what happened? One unpaired electron, they are getting overlapped in the internuclear axis. One sigma bond is formed. After getting one sigma bond, one more unpaired electrons we have to form one overlapping to form one more sigma bond. But what happened you see? The p orbital, when you want to get sigma bond, they have to form internuclear axis. But already one internuclear axis is formed, one overlapping is completed. If you want to form one more internuclear axis, so on the axis only the p orbitals should be bended and the p orbital should be overlapped. But here the p orbitals are getting 90 degrees, so you are not able to form one more internuclear axis in between same atoms. So what happened here you see, the 2 p orbitals which are having unpaired electrons, they are not participated in internuclear axis. How they are overlapped? They are called laterally they are overlapped. How they are overlapped? Laterally they are overlapped. So lateral overlapping is occurred. One more bond is formed. That bond is called pi bond. So what is the bond? It is called pi bond. So here you see the oxygen and one more oxygen. The p orbitals, they are overlapped to form the sigma bond. Here one unpaired electron we have in one more p orbital. The unpaired electron we have one more p orbital. They are not overlapped in the internuclear axis. How they are overlapped? They are overlapped laterally. And what the bond is you are forming? The pi bond you are formed. So you see in between the oxygens, the 2 bonds are formed. One is due to p orbital overlapping, internuclear axis overlapping. What bond you are formed? The sigma bond you are formed. And one more bond also formed. But it is p orbital only involved, but is not in the internuclear axis. It's laterally overlapped and one pi bond you are formed. So in between the oxygens we are getting 2 bonds. One is sigma bond, the another one is pi bond. So always you remember. So in between the two atoms, you are not able to form one sigma. You are not able to form one more sigma bond. Only one sigma bond is formed. So the remaining all pi bonds only. So like that, the VBT is explained about the bonding. So as per VBT, how the bonds are formed, we discussed. So we have to calculate one charge, that is called formal charge. So what it is? Formal charge. So what they involve in the covalent bond. So each and every atom, what it is having in the covalent bond, the compound is having some charge that we have to calculate. It's called formal charge. So atoms involved in covalent bond, the atoms involved in compound formation. So we have to calculate the formal charge. How we are calculating? So here what we have to calculate, what is the principle for formal charge we are discussing. The first, what are the outer shell electrons, that is valency electrons, so minus. So what are the unshared electrons? Unshared electrons, they are formed, it is called unshared electrons, minus, it is 1 by 2. So the total bonded electrons, in the compound. So the total bonded electrons, that atom, how many bonds it is formed, that atom having bonded electrons, we have to calculate. So by this we have to get the formal charge. What is the principle? Formal charge, the valency electrons of that particular atom. So how many unshared electrons we have in that atom, and how many bonded electrons we have in the atom, that we have to calculate. For example, we take one example, that is pH3, phosphine. So we have to calculate the formal charge for phosphorus, formal charge for hydrogen we calculate. So phosphorus, you know, the atomic number, it is 15. What is the electronic configuration? Is 1s2, 2s2, 2p6, 3s2, 3p3 is the electronic configuration. So what is the valency shell? It is 3s2, 3p3, the third orbit is the valency shell. So in the third orbit, valency shell, how many electrons we have? 5 electrons we have. So the phosphorus is bonding with 3 hydrogens. So here, that's 2s2, 3s2, 3p3. In s orbital 2 electrons, in p orbital we have 3 electrons. So how many unpaired electrons we have? 3 unpaired electrons. The 3 unpaired electrons are bonded with 3 hydrogens. So pH3 is formed. So one pair, the pair which is not participated in covalent bond, we have one pair. So that is pH3. So here 3 bonds are formed, one lone pair we have, so which is not participated in covalent bond. Now we are calculating the formal charge for pH3, the formal charge for P we are calculating. So what is the valency shell? It is the third orbit is the valency shell. How many electrons we have? 5 electrons we have. So valency shell electrons are 5, minus. So how many unshared electrons we have, which is not participated in covalent bond? Here we have 2 electrons, that are 2 are not participated in covalent bond. So unshared electrons are 2, minus. So here is half into how many bonded electrons we have. You see the 2 electrons between the phosphorus and hydrogen, the 2 electrons between the phosphorus and hydrogen, the 2 electrons between the phosphorus and hydrogen. So how many electrons you have? 2 plus 2 plus 2, 6 electrons. So 2 into 1 by 2 into 6. So here what we are getting, it is 5 minus 2 minus 3. So what we are getting, it is 5 minus 5, that equal to 0. In pH3, the phosphorus formal charge is 0. Same similarly for the hydrogen also you calculate. The hydrogen formal charge you calculate. The charge of the hydrogen, formal charge of the hydrogen you calculate. The hydrogen atomic number is 1, 1s1. In 1s orbital we have 1 electron. So here the first orbit is the outer orbit. The valency orbit is the first orbit. How many electrons we have? Only 1. So the valency electron, that V equal to 1 only. Here the hydrogen 1 electron is involved in the bonding. So we don't have unshared electrons. So unshared electrons are, it is 0. And how many bonded electrons you have? This electron is involved in the bonding. So the 2 electrons are bonded. So that is 2 electrons are bonded electrons. So here what happened, you see, the valency it is 1 minus, so unshared electrons it is 0 minus half into, it is how many electrons are bonded? It is 2. So 2 to the 1. So that is 1 minus 1, that equal to 0. So here also the hydrogen is getting the formal charge 0. So like that we calculate, that is formal charge in the covalent compounds. The phosphorus and hydrogen we are calculating the formal charge. So what is the principal? It is the valency electrons minus unshaded electrons in the atom minus, that is 1 by 2 into total bonded electrons. So by that principle we calculating the formal charge. So in the chemical bonding, about the covalent bond we are discussing. The covalent bond, how the covalent bond is formed. Here we have three theories. The one VBT already we discussed. The second theory is called valence shell electron pair repulsion theory. It is called Vesper theory. So as per Vesper theory, how the bond is formed, we are not able to explain how the bond is formed. Just for the shape of the molecule only we can explain with the Vesper only. Why? Because in the valence shell we have some electron pairs. The electron pairs, in between the electron pairs we have the repulsions. To minimize the repulsions, the molecule is spatially arranged. So to minimize the repulsions, the molecule is arranged in the shape. So automatically as per with Vesper, so we can calculate, we can introduce only the shape of the molecule. So how the shape it is, how it is a molecule, the atoms are oriented only, we can discuss with the Vesper theory. So what is the electron pairs we have in the valence shell? Now one by one we discuss, with one example we discuss. So for example, I am giving one example, that is H2O molecule. In H2O molecule, the oxygen atom I am taking, the atomic number it is 8. So what is the electronic configuration? Is 1s2, 2s2, 2p4. So outer shell electron, the outer shell is valence shell, the second shell is the valence shell. In s orbital we have 2 electrons, in p orbital we have 4 electrons. So this one is called valence shell. In valence shell, the oxygen, so it is having 2 pairs and 2 electrons are unpaired. So that means in the oxygen we have 2 unpaired electrons. The oxygen can form only 2 bonds. Why? Because already we discussed. So how many unpaired electrons we have? That is equal to the covalent bonds. So in the oxygen we have 2 unpaired electrons. The 2 unpaired electrons only bonded. So that's why the oxygen is having 2 unpaired electrons. The 2 bonds are formed. Here in the oxygen you see the 2 electron pairs which are not participating in covalent bond, and the 2 unpaired electrons we have. The 2 unpaired electrons are bonded with hydrogen. The hydrogen is 1. In the electronic configuration is 1s1. In 1s orbital we have 1 unpaired electron. The hydrogen unpaired electron and the second hydrogen unpaired electron, it is bonded with oxygen. So the totally we have octet form. The oxygen is getting the octet. Here around the oxygen you are getting the electron pairs. So in the valence shell, so outer shell, the electrons are paired. Here the electrons are paired. So in the valence shell electron pairs are formed. In the oxygen when you see, so here the 4 pairs are formed. So in the 4 pairs, the 2 pairs are not bonded. The 2 pairs are not involved in the covalent bond. That's why the 2 pairs are called lone pairs. The 2 pairs are called lone pairs, and the 2 pairs are formed because of hydrogen bonding. So automatically the 2 pairs are formed. The 2 pairs are called bond pairs. So you understood. So oxygen is having the electronic configuration 1s2, 2s2, 2p4. Outer shell it is 2s2, 2p4. In s orbital we have 2 electrons. In p orbital we have 4 electrons. So 1 is paired and 2 are unpaired. So around the oxygen we have 4 electron pairs are formed. In that 2 are not participated in covalent bond and the 2 are participated in covalent bond. So the 4 electron pairs are formed. In that 2 are not participated, so they are called lone pairs, and the 2 are bonded, so they are called bond pairs. So around the oxygen we have 4 pairs. In that 2 are lone pairs and the 2 are bond pairs. So as per valence shell electron pairs, so in between the electron pairs we have the repulsions. That repulsions, so what are the repulsions we have in this oxygen? It is in the H2O. Now we show. So here you see the H2O, here it is oxygen. The oxygen is having 2 pairs and 2 are bond pairs. So this is the lone pair, and similarly this is the lone pair, and it is the bond pair, and it is the bond pair. The total totally we have 4 pairs. In that 2 are lone pairs and 2 are bond pairs. So here we have the electron pairs around the oxygen. The valence shell we have the electron pairs. In between the electron pairs we have the repulsions. That repulsions, so because of the repulsions, to minimize the repulsions, the molecule is shaped. So how it is, you see? So here the 2 lone pairs are we have. The 2 lone pairs, in between the 2 lone pairs we have the repulsions. That repulsion is called lone pair repulsion. What is the repulsion? It is lone pair repulsion. Then lone pair and bond pair, here also we have one repulsion. That repulsion is called lone pair and bond pair repulsion. So in between the bond pairs also you have the repulsions. That repulsion is called bond pair repulsion. So here in the water molecule, the oxygen is having 4 electron pairs. That 4 electron pairs, in that the 2 are lone pairs and 2 are bond pairs. So how many types of repulsions you are forming? 3 types of repulsions you are forming. So in between the lone pairs you are getting one repulsion. The repulsion is called lone pair repulsion. So in between the lone pair and bond pair you are getting one repulsion. The repulsion is called lone pair bond pair repulsion. In between the bond pairs you are getting one repulsion. That repulsion is bond pair repulsion. So here you see these 2 lone pairs are very free. They are not bonded. The 2 electron pairs are free. Why? Because they are not participating in covalent bond. So because of this freeness, the 2 pairs, the 2 lone pairs are having very much repulsions. So that means in this 3, the lone pair repulsion is very high. So here you see the lone pair and bond pair. So one is free and one is bonded. The 2 are fixed in that bond. The 2 electrons are fixed in the bond. The one is free and one is fixed one. So automatically when you compare these 2 lone pair repulsion, you are getting the less repulsion only. So here the lone pair bond pair repulsion. Here you see the bond pair. The 2 electron pairs are fixed in the bonds. So that's why when you compare with the other repulsions, the bond pair repulsion is very less. The bond pair repulsion. So based on these repulsions, the molecules get arranged. So to minimize the repulsion, how many repulsions are we have in that molecule? Based on the repulsions, the molecules get shaped. So how they are shaped? We have one tabular form. Based on the tabular form, we will get one by one.